Hello everyone. So let us just summarize what we studied in the last class. So we were seeing Verilog coding techniques. So Verilog HDL is what we are seeing. The reason being we'll describe the hardware in terms of a code, and then we'll use that code we'll burn that code into FPGAs or ASICs. That becomes so complex digital systems will be easier to implement. So we saw the three different modeling techniques in Verilog, which was structural or gate level modeling, data flow modeling, and behavioral modeling. So in gate level modeling, we use the gate names like AND, NAND, etc. And data flow modeling, we'll be using the symbols. So gate level modeling, we use directly the gate names. This is where we started with. Now in data flow modeling, we started just like writing the Boolean equations using the operator symbols, ampersand, or, not, XOR, XNOR, etc. And in behavioral modeling, we started always at star, begin and end. Here is where the Verilog code we started, we were writing. So let us see an example. Already we have seen one example in the last class. So develop Verilog code to implement F equals A plus B into C, so using the three modeling techniques. So let us first draw the diagram so it becomes easier for us to write the Verilog code. So this is A and B. These are the two inputs. So this is our OR gate. Then we have the AND gate. So I am naming the OR gate so that it becomes easier for us to write the code while using structural modeling. So this OR gate I am giving the name OR1. This only one AND gate is there, so that is AND1. There is an intermediate output. So this is an intermediate output. That output corresponds to A or B. So this is the intermediate output, that is A or B, and the final output is A or B into C. So this intermediate outputs will be represented using a keyword which is called a wire. So a wire represents an intermediate outputs, and we could give the name like x1 equals A or B. So this is the intermediate output x1 which should be defined as a wire. So let us see the structural modeling technique for the above circuit diagram. So like I told, there is an intermediate connection or output after the first OR gate. So the intermediate outputs has to be defined using as wires. So a wire represents a physical connection between two hardware components. So it carries a signal, but it will not store a value. So it carries a signal which is 1 or 0, but it will not store a value. So the syntax is wire and the identifier name. So in our case, it will be wire x1. So above example, like I have told earlier, x1 equals A or B. So let us write the Verilog code. So like we discussed, it starts with module. Give the module name bool1, outputs and the inputs. So y, A, B, C. Y is the output, A, B and C are the inputs. The intermediate outputs we will not mention here. Okay, this is only the direct inputs that is coming to the circuit, and what is the direct output, the final outputs that is coming out of the circuit. So next we'll define y, which is the output. Then the inputs are A, B and C, that also we'll define. We have an intermediate output. So in structural modeling, we'll define it by wire x1. So that is for the intermediate output A plus B, A or B. Now we'll define the gate level modeling or structural modeling. The first is the OR gate. So this is an OR gate. So we instantiate an OR gate. Or the name of the OR gate is like I have shown in the diagram, OR1. So OR1, the output for that OR gate is a wire which is x1, and the inputs are A and B. So this will give the output as x1 equals A or B. Now our final output y equals A or B and C, which will be equal to x1 into C, x1 and C. So we'll instantiate an AND gate. The name of the AND gate, like I have shown in the circuit diagram, that is AND1. The output is Y. So x1 corresponds to A or B multiplied by ANDed by C. So the module ends. Now in data flow modeling, the only difference, like I told, is we'll write it like in terms of Boolean expressions, and then we'll also use the keyword assign, and the Boolean expressions we'll write using the symbols. So again, the module definition remains the same, the output remains the same, the input remains the same. We'll define the intermediate output as wire. Then we'll write assign, which is the keyword we have to use in data flow modeling when we are writing the Boolean expression. The intermediate output, which was a wire, x1 equals A or B. So this is a symbol for OR, like we have discussed. Then again the final output y equals a or b ANDed by c. So assign y equals x1, which is a or b ANDed by c, and the module ends. Now comes the last one, which is the behavioral modeling. In behavioral modeling, we need to remember the wire gets replaced by register. So we cannot write a wire in behavioral modeling. Instead, we have to write it as a register. So the output has to be declared along with the register. So in data flow modeling and structural modeling, we define output as y, right? But in behavioral modeling, we have to define the output as output reg y. So by default, the output will be declared as a wired variable. But in the behavioral modeling, you have to define the output using as a register. It's not a register, it's not storing a value, but while using the behavioral modeling, the output has to be declared as a reg. So again, the module definition and the inputs and the outputs remains the same. The input is ABC. The only difference is, instead of in the structural and the data flow modeling, we declared the output as output y. Here we will declare it as output reg y, and the wire also. In the earlier modeling techniques, we used wire for the intermediate outputs. That also has to be replaced by reg x1. So reg x1. Now always at star, that is how the behavioral modeling starts. So always at star, and the code we'll write in terms of in between begin and end. And in the previous code we wrote it using if and if else statements. Instead of that, you can directly use the Boolean expression what we wrote for the data flow modeling. There is no need to use assign comes in data flow modeling. So x1 equals a or b, y equals x1 ampersand c. There is no need to write the corresponding assign expression, assign keyword, just like in data flow modeling here for a behavioral modeling technique. Instead of this, if you write the truth table, from the truth table also we can write the code corresponding using if else statements or case statements, expressing the circuit behavior rather than writing the Boolean expression. That way also we can do, which we saw in the earlier lecture. So the only thing what I wanted to again remind you is the output has to be declared as a reg. That you need to remember. And the intermediate outputs, instead of wires, that will be also declared as reg. So that's it. We'll in the next lecture we'll show the corresponding Verilog code for the other circuits. Thank you.